everyone. I'm Ching-Chih and I go by Amber, so you could call me Amber. I'm an undergraduate student from National Cheng-Yi University, Taiwan. And today I'll be happy to introduce our paper assessing the decision-making process in human-robot collaboration using a Lego-like EEG headset. So in recent years, human-robot collaboration has been gaining a lot of popularity, and as the role of robots shifted from being a supportive machine to a decision-making collaborator, trust in automation has become essential for a successful collaboration. While we might think that a robot that is highly autonomous can lead to better performance, that it is impossible to provide perfectly reliable human-robot systems in real life. So that blindly trusting a robot does not sound like a good idea. And also, in some cases, robot may not be capable to handle real-world situations, and human may actually outperform robot too. So in our study, we will manipulate 3 factors, including task difficulty, individual ability, and robot capability, to see their influence on human-robot collaboration. Okay, there are a few key questions we would like to explore in our study. And the first one is, we would like to know how an individual's knowledge level has an impact on their reliance on robot suggestions. So will people tend to rely on their own judgment or on robot suggestions? Secondly, we would like to know how robots' capabilities affect user acceptance of the provided aid. So will they be able to identify the knowledge difference between 2 different levels of robots and trust more on the high capability robots? So this is our approach to the research questions. We have 6 student participants in our study, and based on their pretest performance, they were split into 2 groups evenly, which is the high computational thinking group and the low computational thinking group. So the participants will team up with 2 robots in 2 rounds, which is one is the low capabilities robot and the other one is a high capability robot. The participant will answer 6 questions in total in 1 round, which includes 3 easy questions and 3 hard questions in 20 minutes. And the low capability robot can answer 2 out of 6 questions correctly, while the high capability robot will answer 4 questions correctly. After each round, participants were asked to complete the survey that measures their cognitive effect, and that includes the negative attitudes toward robot scale and the NASA TX workload surveys and the robotic social attribute scale. Yeah. Our participant will first work on the given task, and after they provide their initial response, a chatbot will pop up and give out suggestions. And at that point, the participant may have an option to choose to accept the robot's suggestion and submit a final answer, or to reject the suggestions, stick on their original decision. So as you can see on the picture, this is one of our participants engaged in the experimental task, and they work on the Babros task on the computer, which is a website. And when they are working on the task, we collect brain activity data from the EEG headset, which is the electroencephalography headset, and to collect their brain activities for further analysis. Now let's talk about the experimental test, which is the Babros computing challenge. This is a computational thinking competition that is held in over 50 countries. And the goal of this challenge is to introduce informatic concepts and computational thinking ability. The participant will answer questions that focus on computational and logical thinking. So we selected 18 questions from this challenge, and they were divided divided into three rounds of tests. And okay, so there were two kind of questions. For the easy questions, which is the questions that have a correct rate above 50%, and the hard questions have a correct rate of below 50%. So the table shows the scoring system of these questions. So for each correct answer in easy question, the participant will score 6 points, and they will lose 2 points if they submit an incorrect answer. And the hard questions were twice as many points as the easy one. Okay. Now let's move on to the EEG HICSS. So the picture is the EEG HICSS we use in our study, and all the components that connected the headset were 3D printed, which allows us to flexibly adjust the electrodes placed on the head. Yeah. And in total, we use 8 electrodes in this study, and 6 of them are placed in the prefrontal cortex, and 2 of them are placed in the temporal-parietal junction cortex. So the prefrontal cortex is to measure the cognitive activities and and the decision-making process. And the temporal-parietal junction is more to collect information of their visual and somatal systems. So in terms of analysis, we look at three 5-second time windows, which is there is phase 1 to phase 3. So for phase 1, which is before they submit their initial answer, it reflects to how they proceed these tasks. And for phase 2, which is after they receive the robot suggestions and the time they decide to whether to accept or reject the suggestions. So phase 2 is more of our most important focus in our study. And phase 3, which is before they submit the final answers, reflected their certainty to their final answer, and also reflected to the duration of decision-making process. And the tables show that the meanings of the frequency bands. So after we collected the EEG, the brain activity data, we extract the frequency band as a feature. And for alpha band, it represents the focus status of a relaxed status of brain status. And for beta wave, it's about the mental activities. And low beta represents a more active low beta represents how is the participant concentrating. And mid beta and high beta refers to different levels of participants' energy and anxiety. As I just mentioned earlier, the participants completed the survey results. So this is our result. And first of all, although the difference is relatively small, high CD participants have slightly more negative attitudes toward the high capability robot. That shows that the good performance does not always create positive feelings of participants. The second is the Rosas survey, and that shows that both high CT group and low CT group's participant scored the high capability robot with a higher competence score. That shows that participants were able to identify the difference of robot capability. And the last one is the NASA TRX workload survey. So the workload of working with low capability robot is slightly higher than collaborating with high capability robot, which is kind of like as expected. And this is the tax performance of both high CD group and low CD group. So first, and overall, the high CD group outperformed the low CD group, regardless of the robot capability, which is as expected. And the other point that is interested, is that you can see that the when HICSS group work with the low capability robot, their the point fails from 16.67 to 6. So the huge drop shows that HICSS group may be over-trusting the robot. And that is the EEG topography map we illustrate. And this is to see their brain activity difference between groups. So when the HICSS group is validating the robot's answer, the beta waves are more active at the right prefrontal cortex. So this means that they are more focused when validating the robot's answer, and they have a more active decision-making process. And what's more is that the HICSS group, the brain activity varies along phases transitions. So as you can see, the map for phase 1 and phase 3 are pretty much look like the same, but the one for phase 2 is obviously different. So this is only being seen in the HICSS group, so maybe an important pattern that we identified. Next, because we saw the over-trusting problem, so we looked into the HICSS group and find participant number 2 and participant number 3 has a different decision-making patterns. So as you can see, participant number 2 and participant number 3 score the same when they are collaborating with the high capability robot. But when working with the high capability robot, participant number 3 scored 16 extra points, which is a lot. But on the other hand, when participant number 2 worked with the low capability robot, her points drastically dropped from 30 points to negative points. So that is what we identified, that participant number 3 may be appropriately trusting the robot, while participant number 2 is over-trusting. This is the topography map of participant number 2 and participant number 3. Both of them accept the robot's suggestions, and participant number 2 changed the correct answer to an incorrect suggestion, and participant number 3 corrected her answer, which is originally wrong. So let us see the difference. So overall, we can see that participant number 3 has a higher brain amplitude powers across all band and phases. And we can see that in low beta and mid beta, there is a similar pattern to the HICSS group's patterns. So, which is that they have a more active brain powers in phase 2 and at the right prefrontal cortex. And next is the alpha band. That participant number 3 has a higher alpha band in phase 2, which means that she is more relaxed when doing the decision. And the other point is, it cannot be seen really clear here, but there is slightly higher power in phase 3. That means that participant number 3's decision-making process lasts longer than participant number 2. So, as this is a pilot study with a small sample size, we cannot actually provide a conclusion of our result, but we did find some interesting findings and would like to share with you. So the first is the low capability robots had a negative effect on the test outcomes for the especially for the HICSS participants. That shows that if the HICSS participant work by themselves, they might perform even better when they work with a low performance robot. And the second point is that better decisions are made when the brain generates active beta waves at the right prefrontal cortex, as the beta waves is closely related to alertness and mental activities. And prefrontal cortex is closely related to decision making. So active beta waves can help the participants to make better decisions. And the third part is appropriate trust to robotic agent suggestions require a longer decision process. So that is seen in like the active band-powered till phase 3. Okay, so overall this study presents a method that combines EEG and survey data. So although our participant sample size is relatively small, there is something that we can still validate our research design through our experiment. And first is the EEG topography map. So you can see the difference between groups and also between participants. So that explains the difference in participants' reliance behavior. And the second is the Barros test is capable to assess an individual's computational thinking ability. And the third part is the differences of robot capability heavily affected the test outcome. So that can be seen in our test performance data. And in our future study, we will definitely recruit more participants, and that will allow us to develop robotic agents that could best support the participant with diverse expertise. So that is the end of my presentation. Thank you.
Any question for our future researchers? Go ahead.
I understood you had in your process that the participants first get the answers to the toys, then get the recommendation of the robot, and then get the final answer, right?
Yeah.
That was the process.
Yeah.
So, did you think about it? Oh, first of all, thank you for the presentation. It was really interesting, especially the pictures of how the brain is working. I think that's really good insight. Did you think about what would happen if the participants would get the feedback if the robot was wrong or right with his or its recommendation? So that if they answer one choice, get the recommendation, give the feedback, or give the answer, then get the feedback if it was wrong or right, and then maybe change the trust level in the robot. Did you think about that?
Yeah, that is our future research plan. And yeah, we would like to have the robot to have more round of interaction with our participants, so that they could like give a first, like one question's first answer, and the robot can give us some explanation of the recommendations, the recommended answer, and the participant can react to that answer again. So that is on our future plan. Thank you.
Please, yeah.
Maybe a question for clarification, if I might ask. But first of all, excellent. Thank you very much. So it was very interesting as well. What have the participants been notified which kind of robot they were working with, if it's in high capability or not?
No, they are just like finding out when they are working on the task. So based on our survey results, the competency score, I think that they can clearly find out that which one is the high capability robot, but we didn't like notify them like in advance. Yeah.
Mm-hmm. But at the end, then after the experiment, or was it after each answer if the robot was right or wrong?
Sorry.
When did you inform the participants?
We didn't inform them. Yeah, like in the whole process. Yeah.
Okay. Yeah. So then it was just really interesting to me that in the low capability group, the participants were really nervous or starting to focus when the robot suddenly gave their answer.
Yeah.
Yes.
Thank you very much.
One question about the Herman talk about overtrust. You want to validate the phenomenon of overtrust by the high CT participant, right? you want to validate regarding the high CT participant with the over trust, okay, to the robot. Yeah, in that kind of results. I'm thinking about in this process after the experiments, do you done certain interview with the subjects to know the deliberation process when they solving the problem? Because for over-trusting, maybe you use an over-trusting, but really it's something to do with the individual's psychological process. Yeah, so I don't know, do you have any kind of reflection process to interact with the subjects? Yeah, I want to, yeah.
In this pilot study, we didn't conduct interviews, but we're like planning for our future research. So maybe we could add a post-experiment interview after this one. Yeah, it would be better to understand what the participants are really thinking. Yeah.
Okay, any more questions? If no, okay, so thank you so much for coming.